Okay, so today we are going to be practicing, continuing with our STAR booklet, but now we are going to be working on booklet 2. So let's go ahead and get started. So just like the first booklet, we have our reference chart. And let's go ahead and look at page number 1. So the first main topic for this booklet is going to be equations and inequalities. 8.8c, I can model and solve one variable equations with variables on both sides of the equal sign. 8.8a, I can write one variable equations or inequalities with variables on both sides that represent problems. 8.8b, I can write the corresponding real-world problem when given a one variable equation or inequality with variables on both sides of the equal sign. And 8.9a, I can identify and verify the values of x and y that represent the solution of two linear equations in the form y equals mx plus b from the intersections of the graphed equations. So let's go ahead and talk about the parts of an equation first. We have our coefficient, which right here is the number in the front of the variable or multiplying the variable. So the coefficient right here is the one that's going to be attached to x. In this case, the coefficient is negative 12. The variable is the letter used to represent an unknown value. So here our variable is x. Our constant is a fixed value or a number that is on its own. Here, the 4 is not attached to the x, it is completely on its own, so this is the constant. This 40 here, we are also going to label as a constant because it is also alone and it is also a fixed value. So let's go ahead and label that one constant. Now let's go ahead and look at the steps to solve an equation. So step 1 is going to be combine like terms if necessary. So let's go ahead and see what that would look like with an example. So I created this example for us to check. So like terms would be like these two 4s. They're right next to each other. They're both constants. So while we can't combine constants and coefficients with variables, so this 4x is different from this constant right here. These are both constants. These are both fixed numbers that are all alone. So we can actually simplify this, and instead of doing plus 4, group them and have 4x plus 2 equals 2x plus 8. So instead of having the 4 plus 4, just make it plus 8. Combine them. Step 2, collect variables on the same side of the equal sign. So our variables, we have 4x and 2x. So right now they're on two different sides of the equal sign. So we're going to make our track. And we're going to decide which one is the little brother and which one's the big brother. Remember, the little brother always wants to follow the big brother. So here is the little brother because 2x is smaller than 4x. So we're going to get the 2x and we're going to move it to the other side. But in order for us to move it to the other side, we need to do opposite operations. So it's a positive 2x. In order to get rid of it, to make it a 0, essentially, we are going to subtract 2x from both sides, because remember we have an equal sign here. Whatever we do to one side, we need to do to the other. So 4x minus 2x is 2x. 2x minus 2x is 0. 0 plus 8 is just 8. So the only thing I have left on this side is this 8. I didn't do anything to it, so I needed to bring it down. And then this side, we took care of the variables. The constant, the plus 2, we didn't do anything to it, so we're also going to bring that down as well. So now, so far, I have 2x plus 2 equals 8. So we did step 2, we collected the variables on the same side of the equal sign. Now we need to collect the constants on the same side of the equal sign. So this 2 is all alone a fixed value. This 8 is all by itself a fixed value. No variables are attached to it, so we need to combine these. Well, we already have the x on this side, so we're going to move the constant to the other side. Whatever side we already have the variables on, we're going to move the constants to the opposite side. We don't want them to be together. So we're going to get rid of the plus 2, we're going to do the opposite and subtract 2 from both sides. So plus 2, a positive 2 minus 2 gives us a 0. 8 minus 2 gives us a 6. So I have 2x, we didn't do anything with that, so I bring it down, equals 6. Now we're going to have to do the inverse operation to get x all on its own. So to remove the coefficient, we're going to use inverse operations. So my coefficient right now is 2. It's attached to the x, but I just want to know what just one x is equal to. So to get rid of the 2, right now it's 2 times x. We're going to divide by 2 on both sides, again, doing the same operation on both sides. So we are going to have 2 divided by 2 is 1. 1x, we just have to write x. We don't need to write the 1 in front of it, equals 6 divided by 2 is 3. So x is equal to 3. So let's go ahead and do an example. Right now you can pause it, try it on your own, and then you can check your answer. So 14x minus 6 equals 2x plus 2. So 14x and negative 2x are my two variables. We need to decide which one's the little brother. Negative 2x, any negative number is going to be smaller than a positive number. So this is going to be my little brother. So I'm going to move this one from one side to join the big brother over here. So let's go ahead and make our tracks. So to get rid of the negative 2x, we're going to have to do the opposite and do positive 2x. So a negative 2x plus 2x should be 0. So we're going to cancel that one out. Here we got to also add 2x because we have an equal sign. Whatever I do to one side, I need to do to the other. So 14x plus 2x, I end up with 16x. I didn't do anything to the minus 6, so I bring it down. And then 0 plus 2, I end up with just 2 over here. 16x minus 6 equals 2. Okay, so now we have to move the constants on the same side. So negative 6 is my constant, 2 is my constant. So to get rid of the negative 6 and bring it to this side, because this side already has my variables, going to move the constants to the opposite side. The opposite of subtracting 6 is adding 6. So to cancel out a negative 6, we would add 6. Negative 6 plus 6 is 0, so I'm left with just 16x on this side is equal to 2 plus 6 is 8. Now our last step, remove the coefficient with inverse operations. So right now my coefficient is 16. We're going to divide both sides by 16. 16 divided by 16 is just 1. 1x is just x equals 8 divided by 16. So we can either do that ourselves or we can type that into our calculator. 8 divided by 16. Click enter, and I get 1/2. So we're just simplifying that fraction. Or if I also want to change it to a decimal, 8 divided by 16, control enter, would give me the decimal 0.5. So my answer could either be written as a fraction or as a decimal, so we need to be able to go back and forth between them, understand that they are the same number. So now we're going to remember how to check our work. We're going to check our work using menu 3-1, otherwise known as end solve. So we're going to do menu 3-1, and then we're going to, inside of our parentheses, type in our equation. 14x minus 6 equals, so here's our equal sign right here under the control button, negative 2x. Remember, the negative button's right here. It's not the same as the subtraction button, so negative 2 plus 2. And then still inside the parentheses, we need to tell the calculator what to find. Well, we're going to say, okay, well, what variable, sorry, this should be negative 2x. What variable are we looking for? Well, we're trying to figure out what x is. So the calculator can't figure it out on its own. We need to write comma x. We're essentially telling the calculator, here's the equation, now find x. So we need to tell it to find x by putting that comma x. We click enter and we end up with 0.5, which is exactly what we got when we simplified our fraction. Let's also review some inequality signs. So y'all guys are going to be seeing word problems right here. I can write an one variable equation or inequality with variables on both sides that represent problems. So we're going to be getting word problems, and we're going to need to be writing equations or inequalities for them. So some of the key words that we're going to be looking for whenever we're going to use this symbol is less than, below, under, fewer than, smaller than, shorter than. This is my less than symbol. So I know it is my less than symbol because of this trick. So L for less than, we're just going to write the letter L. And then we're just going to kind of like squeeze and turn that L. And then this is the less than symbol. So it's just an L for less than that's kind of been turned on its side and squeezed a little bit. So I'm able to get my less than symbol. So if we can't remember what our less than symbol is, because you're going to need to remember it on your own, draw an L and then kind of turn it and squeeze it, and that'll be your less than symbol. Your greater than symbol would just be the opposite of that. So always start off with your less than. So this is our less than symbol. So let's go ahead and highlight that. Less than. And then this symbol right here is greater than. Some of the keywords in our word problems could be greater than, above, over, more than, bigger than, taller than. If we see any of these words, we know we're going to be using that inequality. Less than or equal to is the name of this symbol. At most, maximum, no greater than, and no more than are all keywords that will require us to use this symbol. Greater than or equal to, at least, minimum, not less than, no fewer than are all words that will cause us to use the greater than or equal to symbol. And now let's look at the last topic. The point of intersection on a graph of two linear equations represents the values of x and y that are a solution to both equations. So this is our system of equations when we have two lines on the graph and we are looking for the solution. The solution is just a word for the intersection where those 2 points meet. Your solution is going to be written in this format, x comma y. So you are going to identify, okay, they cross right here. What is the coordinate for this specific point? You're going to find the x value, you're going to find the y value, write it as a coordinate pair, and that will be your answer. So those are the notes for that first topic. Now I am going to help set up number 1 for y'all guys, just so that way we remember how to write an equation when we're looking at those real world situations. So we are going to use what we were using last week, our slope-intercept form, mx plus b. But this time we are going to have two situations. So we're going to write mx plus b equals mx plus, mx plus b. So we're going to have situation 1 and situation 2. And this is how we're going to be setting up our equations in order to solve it. So remember, whenever we're looking at a real world situation, m is going to be our slope. This is also going to be the one in the problem that occurs multiple times. So m multiple, that's how I remember how it's going to go. So multiple, it's going to be the one multiplied by x. By multiple, I mean those words where it says per month. Per month means it's every month, so that's going to happen multiple times. Each year means it's going to happen every year, so it's going to happen multiple times. Yearly, monthly, weekly means every week, every year, every month. So those are the key words that we're going to use to identify which number is m, the slope, or the multiple, the one that's going to be attached to the x, the coefficient basically. And then b is going to be that one-time amount, the one that's going to occur once. So this is our y-intercept. Let's identify that. Or the one-time amount. So if you, in order to get into a park that you're going to play games at, let's say it's 50 cents per game, but in order to just get on the grounds, you need to pay $10. And then after that, it's just 50 cents for every game you play. That one-time amount that you pay in order to get there is your b, or y-intercept. That's going to be the constant, the one that's all alone. Let's say that you are saving money and you have $20 in the bank account, but you're going to go out to a fair and you're going to be buying snacks for $1. Well, your initial amount that one time will also be b. So this is one time or initial. So that's what you start off with. You start off with $20 and then you're going to be taking out $1 for every snack that you buy. So that would be b, your constant. So it's going to be the same for both of them. Just for situation 1, you're going to look at that information, and then situation 2, you'll find the multiple amount, you'll find the one-time or initial amount, and make that b, make them equal to each other, and then we can solve it just like we did the examples on this first page. But let's go ahead and read the situations. So it says a gym A charges a registration fee of $75 plus $35.75 per month for members. Gym B charges a registration fee of $164 plus $17.95 for members. After how many months would the total cost of Gym A and Gym B to be the same for the members? So we have two situations. We have Gym A and Gym B. So we're going to go ahead and set this up. Gym A and Gym B. We are looking for the two gyms to be the same. So for them to be the same, that means that we want them to be equal to each other. So we'll set up our table and make them equal to each other. So let's go ahead and write our equation for Gym A. So we're just going to focus on Gym A's information. A registration fee of $75 plus $35.75 per month. So the registration fee is that one-time fee to register. You only need to register once to use that gym. So that's going to be B. M is going to be the per month value. It's getting charged multiple times. You have to pay $35.75 every month. So that's going to be the multiple. So we're going to write MX. So M, the multiple amount, 35.75x, and then plus B, that one-time or initial amount, plus 75. So that's how we write our equation for Gym A is equal to, and then for Gym B, let's see, Gym B has a registration fee of $164 plus $17.95. So this should be each month. So this is the multiple. So when we are finding M for this situation, $17.95 is the multiple. $17.95, that's times X, so X. Plus, they're also charging them $164. So $164 is that one-time or initial amount, so that's B. So 164. So now we have our equation written. You can do one of two things. You can either solve it by hand. You're going to identify the little brother, move it over with the big brother, because remember, the little brothers always want to follow the big brothers. You're going to move it over, and then you're going to move the constants to the opposite side. Use inverse operations, and then you'll calculate how many months it will take for them to be the same. Or you can also, once you do that, you're going to check it with NSolve. So practice doing the long method, check your answer with NSolve.